Okay, let's have a look at another probability question involving a tree sketch, but this time we're going to be dealing with not fractions as probabilities, but we're going to actually be talking about decimal probabilities, which they sometimes do. These are not common questions, but they do set them from time to time. So the chances of Peter winning the boys' race is 0.3. Chance of Jane winning the girls' race is 0.15. So we've got two races going on, a boys' race and a girls' race. Peter's got a 0.3 chance of winning the boys' race. Jane's got a 0.15 chance of winning the girls' race. Part A, draw a tree sketch, obviously to show the chances of people winning these races. Okay, so part A. Here we go. Boys' race. This is the first one. Okay, what can happen? Well, we can have Peter winning, or we can have somebody else winning. Now, do we know what the other names of the boys are? No, we don't. Does it matter? No, it doesn't. Because all I've got to say is that Peter wins or Peter doesn't win. Peter loses, if you like. Peter wins, Peter doesn't win. Peter wins, Peter loses. Doesn't matter how you phrase that. Something like that. What's the chances that Peter wins? 0.3. So you put 0.3 on that branch. What's the chances that Peter loses? Well, if you've got a 0.3 chance of winning, remember for decimals, the two branches must add up to one whole. The partner of 0.3 is 0.7. He must have a 0.7 chance of losing. 0.3 and 0.7 add up to 1. It's a certainty. 0.3 plus 0.7 gives one whole. A certainty. He either wins or he loses. That's the only options. There are no other options. Okay, so let's say Peter wins. We then have a look at the girls' race. What are the options? Well, either Jane wins, or, in the same sort of way, Jane loses. They are the two options. Peter loses his race. Let's look at the girls' race. Jane wins, or Jane loses. They are the two options. Okay, when it comes to the girls' race, what are the chances that Jane wins? 0.15. So what's the chances that Jane doesn't win or Jane loses? Well, they must add up to give one whole when you combine them. 0.15, the partner of 0.15 is 0.85. So those are the two decimal fractions. Decimals, remember, are fractions, decimal fractions. Those are the two decimal fractions on these two branches. They've got nothing to do with what happens to Peter at all in this particular question. Nothing whatsoever. Okay, it's not like the bead questions where you have without replacement and the figures are all interlocked with each other. Nothing to do with each other. Jane winning and Peter winning, totally irrelevant, totally separate calculations. Peter loses his race, follow this path. Jane wins, 0.15 chance. Jane loses, 0.85 chance. So there you go, there's the tree sketch based on this information. Part B. I'll do part B here. I haven't got much space, but I'll be able to just squeeze it in. Find the probability that Peter and Jane win. Peter and Jane. Well, it's already phrased with the word and in. Peter and Jane win. So I'm not going to rephrase it. I'm just going to go straight to the calculation. Peter wins is 0.3. And gets replaced with a times, and then Jane wins 0.15, like so. So you've got to work that out. And remember, this might be paper 1, no calculator. So you've got to work that out without a calculator. Well, just remember how you multiply decimals. 3 times 15 is 45. So you got 45. In the question, there's one decimal place in that number, and there are 2 decimal places in that number. So altogether in the question there are 2 and 1, 3 decimal places. So that must mean in your answer there must be 3 decimal places. Well, if you put the point there, there are 2 decimal places. You need 3. Now you don't add a 0 on the end, because adding a 0 on the end doesn't change the number at all. That is still 0.45, even though it looks like it's got 3 decimals. It's actually only got 2. Because 0.450, you'd actually rub that out to leave just 2. So how do I adapt this? Well, what you need to do is put a 0 in front of the 45 and make it 0.045, like so. So it's point and then 1, 2, 3 decimals. 0.045 is the correct answer to that. Not 0.450. The O on the end wouldn't count as a decimal place. So 0.045 is the answer to part B. That Peter and Jane both win their races. Okay, and then if I go on to part C, neither Peter nor Jane win. Well, if neither of them win, what we want is Peter loses and then Jane loses. So I'll need to rephrase that. Probability that Peter loses and Jane loses. So that's what neither of them are actually going to be winning the race. So Peter loses 0.7 and times Jane loses 0.85. So there is the calculation you need to do. Now what you need to do is 85 times 7. Let's do that over here. 85 times 7. No calculator. 5 7's 35. 5 down, carry the 3. 8 7's are 56. Add the 3, 59. So you get 595 like so. 1, 2, 3 decimal places. 1, 2, 3. I don't need to add any zeros. I just need to put the point there. There you go, there's a 0.595 chance that Peter loses and Jane loses. In other words, neither Peter nor Jane win their race. And that's the end of this decimal tree sketch probability question.